Okay, this is lesson 80, prime and composite numbers. So prime numbers have exactly two factors, 1 and whatever that number is. Composite numbers have more than two factors. So that's pretty straightforward. 1 is a little confusing because it only has one factor, 1. So it's not prime or composite. If I look at 2, what are the factors of 2? So remember, factors, you can multiply two numbers together to make that number. So 1 times 2 is 2, and there's nothing else, so it's a prime number. 1 times 3, nothing else, so it's a prime number. 4, on the other hand, has 1 and 4, and 2 and 2, so it's a composite number. 5 is prime. 6 has more than two factors, so it's a composite number. 7 only has two factors, 1 and itself, so it's a prime number. Composite, 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 prime. So looking at this list, you notice that almost all of the prime numbers are odd, except for 2. Because all of these even numbers, 4, 6, 8, 10, can be divided by 2. So when you're thinking about prime numbers, you can rule out all the odd numbers. All the even numbers except for 2. Okay, so we'll think about that a little bit more. I wanted to show you something that's kind of neat. Look, the word odd has 3 letters, which is an odd number. The word even has 4 letters, which is an even number. Prime has 5 letters, so it is a prime number. Composite has 9, and it's a composite number. So anyway, just kind of cool. Maybe a way to help you remember it. I don't know. Okay, so in this lesson, the first 3 numbers are 2, 3, and 5. I was going to use this. So what are the next prime numbers? So 2, 3, and 5. So I have 7, 11, and then what comes after that? Can't be 12 because that's an even number divisible by 2. What about 13? 13 divisible by anything but 1 in itself? Nope, so it would be 13. Okay. You're going to talk a little bit about arrays. So an array is a rectangular arrangement of numbers or objects in columns and rows. So you know how I always say multiplication is groups of. So arrays for 12, I've got 3 groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and it's a rectangle. Here, I've got 6 groups of 2. 1, 2, 3, 4, 5, 6. So both of those are arrays based on the factors of 12. This is an array. It's one group of 12. So 1 times 12. And it's still a rectangle, even though my rectangle's a little wobbly. So prime numbers can only have one possible array, just like this. If I try to arrange 5 in a rectangle, I get a weird shape, don't I? I get a compound shape. So I can't make it a rectangle and still have an array. So the only way you can use a different array for this, if something has more than one kind of array, then it's a composite number. Prime numbers will only have one array. Example 2 says, draw 3 arrays for the number 16. So first of all, I like to look at the factors of 16. So what pair of numbers can you make that will make the product 16? So 1 times 16, 2 times 8, 4 times 4, right? So there's 1 times 16, 2 times 8, 4 times 4. You may choose to go the other way, and that's fine. Like if you made this one, turned it sideways, that would be fine. Just for fun, I want it, and it may not be fun to you, but anyway, extra information. So you can always break down composite numbers into prime numbers. It's called prime factorization. You'll do this a little bit later, but boy, it's handy sometimes. So I just thought I'd show it to you. So let's take the number 24. And I know it's a composite number because it has several different factors. 2 and 12, 6 and 4, 3 and 8. So it's got a bunch of different ones. So I'm just going to pick one factor pair. So I'm going to say 24 can be broken down into 6 and 4, right? Do I have prime numbers yet? Nope. Those still can be broken down further. So 6 can be broken down into 2 times 3. And 4 can be broken down into 2 times 2, right? So this part right here, that 2 times 2 times 2 times 3, usually you put them in order, equals 24 is a prime factorization. So it's only using prime numbers to multiply to get to your product. Now it doesn't really matter. I use 6 and 4. I could use 2 and 12, and I'm going to get the same thing. So if I break 24 into 2 times 12, well, 2 is a prime number, isn't it? So let's break 12 down. That's a composite number. 12 can be broken down into 6 times 2, right? Okay, so that's a prime number. So let's break 6 down. 3 times 2. And I still get 2 times 2 times 2 times 3 equals 24. So just a cool thing. Play around with that. I call them upside down Christmas trees because they kind of look like that if you do it, get a really big number. Sometimes it's a nice way to be able to reduce fractions, to manipulate numbers. So, good luck with this lesson. You won't need this part.